Okay. Thank you very much. I'm glad to be here. I'll talk about supercomputer in Brazil and LNCC. LNCC in Portuguese, Laboratório Nacional de Computação Científica. It's Brazilian National Lab for Scientific Computing. It's a lab from the Minister of Science and Technology Innovations. I will start to talk about the lab, not the supercomputer in Brazil, but the lab and how it mixes with the supercomputer in Brazil. Oh, this lab has 42 years old. We complete 42 years now. It's always full of people here. Today is a little bit empty, people working at home, but we are coming back to be crowded here. We have our mission, we can split our mission in 3 missions. First, do research in scientific computer, human research, develop human research, for instance, we have a PhD program here, a doctoral program, and we also provide supercomputing service, so people can run here. I will talk more about this. But our mission is very big. And this lab is not only the campus here, we have a ISO 2001, and that's about security, but you have a business incubator and kernel for innovation here in Rio de Janeiro, have a foundation for pay for research. We have even a society of scientific computer. So we have a lot of institutions. I will talk more about SINAPAD and SINAPAD. These 2 institutions are, let's see if I can show here, SINAPAD and SINAPAD. These 2 institutions that are inside this lab provide supercomputer in several states. Okay, so I told you we've divided in 3 folds. First, research, development, innovation, and normally we study applied math, computer science, system and control, computational mechanics, biosystems, and bioinformatics. In HPC, in high performance computing, we have the SINAPAD that I will have one slide for this. This is a system that controls all supercomputer for academic research. And we have this SINAPAD, it is a center for supercomputer research. I'll talk about this. We also give support for running the programs here, because sometimes people want to run, but has no practice how to run in supercomputers, not like you run in a normal computer, you know. And I will talk very fast. I dropped a lot of slides here about human research and training, because as I told you, we have a doctoral program. We have trainings during the beginning of the year. We have a summer school. We have also science popularization. So we go in several parts of Brazil to how can I say, to advertise science in computer science special, or scientific computer to be more precise. To understand better what's happening here, we will present some projects. So once some selected is hard because a lot of projects are interesting. So I select a few here just to have one idea what we do in this lab. Okay, for instance, oil and energy. We have probably heard about pre-salt in Brazil, that we have a lot of oil and it's very hard to drill this and get the oil. So we have a team working very deep in this and helping the big companies to get this oil, not only to get this oil, but also how to capture the carbon. So you can capture the carbon and store in this kind of stones. So there are a lot of techniques involved here. We have teams working with artificial intelligence for instance, and most with data. We also have people working without data, with equations, but we also have a big team working with big data. I, in particular, I have a group about that we work in security and privacy, and the idea is to encrypt the computational model. See, we are not encrypting the data only. We are encrypting the model, the equations, the program, but in a such way that you can run this program in a supercomputer. Okay, so we have a private key, and we encrypt, send for a supercomputer, process, and get the result. But to see the result, only who has the private key can see the result. Cannot, I mean, it's not, the result's not clear in the machine. So a super user, root administration, they cannot see what's happening, what is the result. Only who has the private key to decipher and understand what's the result from the processing. We have this, for instance, in vote machine, electronic voting. We have a group for virtual reality. You have a cave here. And we study also supercomputer. I have a group of quantum computer. So supercomputers in the future will get quantum. So we are working on this as well. I'll not be very fast here because I understand that the past part here, we talk each other about cooperation and what we can do. But to be short, this algorithm here, this is a circuit from quantum computer, an algorithm that can find a solution in case if you have a data set that's not ordered, you can find it in square n. What means if you have, for instance, 1,000 pages and you search for some specific page. I want searching here for one page. Okay, oh, I want to find this page. I have 1,000 pages. I go, oh, this page. No, not this page. I can go random. I can go back forward. I can, doesn't matter. The worst case is the last page, if I find the last page. But the point is that if you have 100 pages in the last page, the worst case for us in the classical world is 100 try. You should try 100 times to get the right page. In quantum computer, they can do this with 10 try. So 10 steps, 10 times that they search, the quantum computer search, it will find the right page, just 10. So it's much faster, it's quadratically faster. In this algorithm, that's Grover algorithm. So that's why you are interested in this, because every circuit, every single computer program can get faster with quantum computer. But let's go back to our real world. We also have this cardiovascular model. We have companies here working. People are constructing right now a machine to sell this. And the idea is that you do a normal tomography, but instead of having here a generic model for transforming the events in the equations, differential equations, the idea is to have one model for each body. So you can have, with this system, one model for your body, and you can see where, if you have some medicine, where you get more pressure, or where you have no enough oxygenation. You can see what's happening if you change your organism, if you get sugar or salt, and what's happening. Okay, so it is a very business product. People are constructing machine, and there are royalties involved and things that's very real. But we have also some other works that I think are very interesting, but it's very away from the reality again. Because cancer is thermosensitive, that means you can destroy cancer if you induce fever in the patient. But suppose that here, the idea here, here you have a cancer tumor. Okay, it's an ideal model because cancer tumor is not a circle. And you can compute some equations to burn this without touching the patient. So away from the patient, you can burn the tumor. And this is very interesting, but it's more theoretical, not practical like before. And you have also other works with cancer to identify how cancer grow and a specific kind of cells, that's CAR cells. Okay, I think this is very nice. Something very important people are using a lot here. Also, we have a portal on the internet that provide drug designs, and people submit jobs all around the world. They teach people that study pharmacies teach this. Professors teach with this software, but also companies use this software. And we not only do the computation, should I say, not only run in software, we do also genome sequencing and analysis. So the analysis is in the supercomputer, but the sequencing will have special kind of device, biological device to analyze. And this is interesting because I like this slide, because this news here in Portuguese news, they say that Brazil sequencing less and analyze less genomes than in 2020. Brazil analyzed less than 2019. But here we analyze much more during the beginning of the pandemic. So we did a lot of work. So I always proud to present the big team that did this. Most part of the Brazil, in special, all state of Rio de Janeiro, all the state, not only the city, but the state. All vigilance genomics is doing, we are doing till now here in this lab. Okay, we consider that we are interdisciplinary, okay? But if you look for Scopus, we are only 1% interdisciplinary. We consider, because we work with mathematics, computer science, engineering, a lot of things of biology. Even here, we have one paper about psychology, just one paper, that's why almost 0%. We have just one paper about psychology, and this paper, it's a mathematical model with differential equations that describe behavior, how people behave, but based on differential equations. Here we have in our library the publications, here the old books, and these are the new books. I have one here, this book is mine. I have another book that's behind of me here, but we cannot, it's not in the library, it's still not in the library. We have several partners, here's some of them, from Europe, like India, Institut Pasteur, Université de Lorraine, we'll talk more from later. Also BRICS, I represent myself, the lab represents the, in the BRICS, the part of supercomputer. So we are the chair for supercomputer here in the BRICS, to talk with your BRICS. But you can see that our co-authors are on, this is logarithm scale. Our co-authors are few in the BRICS, and this is France, this island in France that belongs to the France. So we can see that more North America, here South America, Europe is the most number of papers that you have a cooperation co-authors. We also are a hub. This professor is today in France. He has a cathedra there. India is a lab in France that works like very similar to LNCC, but they also fund research. They pay for research. In our research that from Brazil that has cooperation with India in France, they use the infrastructure from the LNCC. So we work like a hub for Brazil, and now we want to work, don't tell forever, it's almost secret. You want to tell, want to us work like a hub for all South America. We have projects, not only BRICS, but EU as well. And also CERN. This is interesting because you have a project from CERN that's running here. How it works, that's the point. You have a cooperation here with Brazilian research. The Brazilian research submits the project to our lab, to run in our supercomputer. And a committee will, of course, analyze. And okay, if it's selected, external teams from other countries can run here by means of a cooperation with the Brazilian team. That's what happened at CERN, run here project in LNCC. When I say LNCC, this is our campus, and this is the supercomputer I will talk about high performance computer now. It's in Portuguese, but what's matter here, it's a very old journal 20 years ago that said that we are bringing the supercomputer, the biggest, what's most fast supercomputer in Latin America to this city here, where we are, Petrópolis. We did the first connection to BitNet. That the BitNet was the first network, computer network in the world. And we work later in the internet, but FAPESP in Brazil did the first connection. We work with them. I told about SINAPAD, how it works. We have here 9 centers of high performance computers. This is an acronym in Portuguese. We have 9 centers. The most fast computer is here. The fastest is here in LNCC. And the second fast is in São Paulo. I guess this, if I'm not wrong. And the first is 10 times faster than the second in Brazil. And all this network of supercomputer is coordinated by this system of supercomputers centers. And the center also is here. This system is coordinated also by us in our lab here. Let's see. So we have here people from France that came here, and this computer was constructed in France, the fastest for academic research. When it came, it was away the fastest in Brazil. We call Santos Dumont because Santos Dumont was the first guy to fly in this machine, this aircraft, in France. It's a Brazilian that fly in France for the first time, not for the first time a Brazilian, but for first human being to fly. Okay, and here you have on the wall some certificates, number one in South America, some years ago. I guess this 2014, this is, so, but how is it today? For research, we are the fastest, okay? There's no machine faster than this. Why I say fastest instead of bigger? Because you can see here, this is a very small machine, and I work with much bigger machine. I work with IBM 3090. It's a mainframe that's much bigger than this and much slower than this. That's why I don't like it. How most people use the term bigger. I prefer to say fastest or what you have more efficient, more powerful machine. And today in Brazil, you have 4 machines that are faster in this list, top 500. They are faster, so it's time to upgrade the machine and go back to be in the first, the number 1. And the 2, 3 here machines are from Petróleo Brasileiro, it's oil and gas company. They are faster. And something interesting, this one is this one is from smartphones to run artificial intelligence, and so it's more to specific application, not scientific application. In our machine, also it's interesting because this computer, supercomputer, it came for this list in three positions. So if we could sum the 3 machines, it would be like here. I guess, no, of course, flop, sorry. It would be number 2. Why you cannot sum the 3 positions? Because you have different architecture, and this list analyzes each architecture. So if you could aggregate the architectures, you could be here with 5.1 petaflop and not 4. So we could be in a best position. But anyway, it's time to upgrade. And we still are the most powerful machine for academic research in Latin America. During COVID pandemic, we run a lot of projects. Here I put some projects with nice pictures, but we have run a lot of projects here. And I will talk very quick about human research. As I told, and you have questions to talk. So we start with computational modeling here in the lab. This is a doctoral program, was the first in Brazil. And now I guess we have 20 doctoral programs with this title. We have several, sorry, it's in Portuguese, but we have here in this area 5 students of us that are professors. So we have students around Brazil that becomes professor, not only in this part. We have also students abroad. We have an institution, CAPS is an institution, a governmental institution that evaluates the doctoral programs. The maximum score is 7. In our area, the maximum score is 6, and our score is 6. Because we have also maximum score for area. So, thank you very much. Graças, spasiba, xexê. Danke, merci, obrigado.